Imagine standing on a beautiful, sun-drenched beach. The vast ocean stretches out before you, a shimmering expanse of blue. Waves crash rhythmically against the shore, a timeless sound. Yet, for humans and so many creatures, this abundant water is not drinkable. Ocean water contains many dissolved minerals, and common salt, sodium chloride, is the most plentiful. Over vast eons, rivers have carried tiny amounts of mineral salts from rocks and soil into the sea. As water evaporates from the ocean surface, the salts are left behind. This process has made the ocean salty, far too salty for our bodies to handle. Our kidneys cannot cope with such high concentrations of salt. Drinking seawater can cause sickness, kidney damage, and ultimately, it can be fatal. Surrounded by so much water, one could perish from thirst. Many communities live in arid regions close to the sea, yet they lack fresh water. They face daily struggles to find enough clean water for drinking, for farming, and for hygiene. The world's population is growing, and the demand for fresh water is increasing. Climate change can also make water scarcity worse in many areas. Finding ways to safely use the ocean's water is therefore a task of great importance for humanity. Our planet has its own wonderful way of making fresh water. We call it the water cycle. The sun shines on the oceans, warming the surface. This warmth causes water to evaporate, turning from a liquid into a gas called water vapor. When this happens, the salt and other minerals are left behind in the sea. Only the pure water rises into the atmosphere. This is nature's own desalination plant working on a colossal scale. This water vapor then travels with the winds. As it rises higher, it cools down. Cool air cannot hold as much moisture as warm air, so the water vapor condenses. It turns back into tiny droplets of liquid water or ice crystals. These droplets and crystals gather together to form clouds. These clouds drift across the sky, carried by air currents. Eventually, these water droplets or ice crystals in the clouds become too heavy. They then fall back to Earth as precipitation. This fresh water replenishes our rivers, our lakes, and the groundwater beneath our feet. It nourishes the land, allowing plants to grow and animals to thrive. This natural cycle provides the fresh water that all life on land depends upon. For many years, scientists have explored more efficient ways to remove salt from seawater. One common method is called reverse osmosis. This technique uses high pressure to force seawater through a special membrane. This membrane acts like an extremely fine filter. It has tiny pores or holes that are small enough to block the larger salt molecules. However, the water molecules, being smaller, can pass through. This process requires a lot of energy to create the high pressure needed. A remarkable breakthrough came with a material called graphene. Graphene is an extraordinary substance. It is a single layer of carbon atoms arranged in a honeycomb pattern. It is incredibly thin, just one atom thick. Yet it is immensely strong, stronger than steel. Scientists realized that graphene could be used to create a new kind of super-efficient filter. These graphene-based nanosieves are a marvel of modern science. This technology is still developing, but it holds the key to abundant fresh water. The dream of turning seawater into fresh water is not just for large industrial plants. Innovation is also bringing this power to individuals and small communities. Consider the remarkable invention of a backpack desalinator. This is a portable device, small enough to be carried by one person. It allows someone to produce drinking water directly from the sea or from other brackish water sources. It requires no electricity and no high-pressure pumps. It is a truly life-changing piece of technology for those in need. Imagine a disaster relief worker or a remote coastal village having this capability. It means immediate access to life's most essential resource. The impact of such portable desalination units is profound. In the aftermath of a hurricane or an earthquake, normal water supplies are often disrupted. These backpack systems can provide clean drinking water for survivors and rescue teams. This technology empowers people, giving them control over their own water security. While reverse osmosis, especially with new materials like graphene, is a leading technology, scientists are also exploring other gentle methods. One such promising alternative is called forward osmosis. Unlike reverse osmosis, which uses high pressure to push water through a membrane, forward osmosis uses a natural process. It relies on the difference in concentration between two liquids. A special draw solution, which has a very high concentration of solutes, pulls water molecules across a semi-permeable membrane from the seawater. The salt from the seawater is left behind. The clever part of forward osmosis is then separating the fresh water from this draw solution. Scientists are developing draw solutions whose solutes can be easily removed, perhaps by a gentle temperature change or another low-energy process. This could make desalination significantly less energy-intensive than traditional methods. This method also tends to cause less fouling or clogging of the membranes. The future of turning ocean water into fresh water is bright. Imagine sophisticated, efficient technologies, AI-controlled desalination pods, deployed quickly to any location. AI monitors water quality and optimizes energy use, powered by renewable energy, making freshwater production sustainable. Renewable energy is crucial for desalination. Traditional plants are energy-intensive. Clean energy reduces carbon footprint. Coastal communities with solar-powered units, floating plants powered by wave energy. Innovations make desalination greener, a testament to human ingenuity, unlocking the potential of our oceans. Clean water access is fundamental. A future with abundant fresh water is within reach.